Hello again everyone. In this video I just wanted to go through another use case that we've been toying around with for the Florence-2 vision model from Microsoft. And so what we've decided to try is automated image tagging. We have some images in a directory, here you go, and it's just different images of different weapons that we wanted to see if we could tag for training later. They're going to be exported into this data directory. It's going to have the YAML file as well as be split into 75% training, 25% test, and 5% validation. Let's go ahead and give it a run through and see what we get. I'll walk you through. Here we're loading the libraries. I just checked the CUDA specs. Here's our function to get all the images in the directory. Here's the function to write the YAML file. This is how we actually pass in the caption to phase grounding for the model parameters. Then here's how we just render the image with the bounding boxes. So we'll see it actually in the notebook. This is for the writing of the actual label file of the bounding boxes. Here's where we actually write the component file to the image file to actually put in the bounding boxes for the labels. And here we have it kicked off. So we just have it, the data directory, the data YAML, then it's going through and getting the file path. So we're looking for gun, that's the text input. And here we go, we're running through it. Create our directory, create the YAML file, write the YAML file, and here's where we're passing this task to Florence using the caption to phrase grounding. Here's the directory we're looking at is the images, getting the list of all the images. Then we sort it with nat sorted to make sure that it's sequential. And then we go through and process each file. So you'll see as we go through, we write the which image is processing, then we get the results back from the model, we create the text file, load the results in the text file, and then we just print out the results, as you can see this right here, and then we actually render the image with the bounding box so we can see it in the notebook. Like I said, I think we have like 50 images, and you can see for each image, this is the results from the Florence model. And scroll through all of them, and you just see it's doing pretty good. It's actually finding the gun in each of these images. It's actually still running the annotation. It's doing a pretty good job too. I'm really impressed with the Florence model for this. So like I said, we're only doing 50 images here, but if you can imagine running through a data set of, tens of thousands or hundreds of thousands of images, how long that would take. But, with some human oversight, due diligence, this could probably take a matter of hours as opposed to days or weeks. And so here's our function to split our training test data and sort everything, create the correct directories, and move everything into those directories for training later. We did a data split of 50 images, 37 went into training, 7 went into test, and 6 went into the validation directory. And what I wanted to do is show you a way to get a random image from whether it was train, test, or validation, match it with the label text file that actually contains the bounding box coordinates, and then load it up and render it to make sure that on par with what we need it to be. So I put a little print statement here to stop it, but it loaded up everything. So let's go ahead and check a random image. So here I have just getting a random choice from the different directories, pass it in, and then let's render what we get. See, it's pretty good. I picked up the image, and that's 030, the image 030 from the test directory. Another from the test directory. Oh, I have it set here. Let me just go ahead and change this to random item and make sure we actually, because it is set to only the test directory, so I want to kind of, there. So that's from test as well. Still going into test. There it is. There's one from validation. But if you notice, the bounding boxes are pretty accurate, so the annotation is really good, just initial pass. And it's actually picking them all up. See, there's another test. I'm going to see one from the training directory. There's one from validation. There's one from the training directory. So looking pretty good. So now let's look in the data directory to kind of see what happened. So here's our YAML file. I could be better at formatting this, obviously, but it wrote the YAML file. Then here's our test data, and you see it's separated images with their corresponding labels. Same with training. All your training images. It doesn't actually have the labels in it, just the bounding boxes get rendered. Same for validation. Images and the bounding box. Once again, the use case is automated image annotation. Thank you for your time. 125.